Hi everyone, so if you are watching this video, you are probably interested in how to make a FPV camera for your Lego vehicle, and I will show you how to do this in this video. So you will need just a few components. Of course, you will need the camera and the board to connect to computer to upload the sketch. This is the remote hub that we use to power this camera. Next, you will need a PCB. This one is 30 millimeters width, and this is a little bit smaller, just the same size as the camera. Of course, you will need some pin headers and some wires. Also, you will need a connector to get the power from the hub. This is basically an extension cable. I just cut it and soldered the connector. So one connector is here. This is going to work like this, and this is the connector for the PCB. I'll solder it later somewhere here. And what's important, the hub provides 7.4 volts, which is too high to power the camera module. So you will need a voltage regulator. So the schematic that is shown in the video shows an LM7805 voltage regulator, which is quite old, and you should not use it. It's present on the schematic just because I did not find the modern buck converter in the software I used to draw the schematic. So don't use this old component. Instead, you need to find a smaller buck converter. It does absolutely the same. So the left pin is input voltage, the middle pin is ground, and the right pin is output voltage, which is 5 volts for the camera. So there are also some capacitors. They were needed for the old regulator, but since we are not using the old regulator, we will not use no capacitors. This modern buck converter works perfectly even without capacitors. So now I'm going to solder these components on the PCB. I will not be showing the process because it is quite simple. I will show you the results. So this is the PCB. It is 30 millimeters width, which is exactly the width of the ESP camera model, so it will fit. Now you need to make holes to fix the PCB with your Lego vehicle, and I'll show you how to do that quite accurately. So first of all, you mark the width of the PCB, and then you make the holes somewhere near the center of the board. So we are going to make 2 holes. The distance between holes will be 16 millimeters. That is 3 studs wide of Lego. So here is the center. This is 1 point, and this is the other point. So here will be the holes for the studs. And it is very important to fix the PCB while you are drilling, so it will not move. I'll fix the PCB with very small screws here. So now I start drilling. So the PCB is now ready. You can see the buck converter under the camera, and the connector is on the other side. So now it's ready, and it's time to upload the sketch for the camera. This is a standard uploading model. Well, you can go ahead with the standard ESP32 camera example. It's here. Or you can get my code. It's based on the official example, but it has some fixes. So the main fix is that the camera frame rate is limited and the resolution is very low. So with a lower resolution you can get more frames per second. And there are also some minor enhancements, so the camera is available on your network with a host name. So if you use my example, you need to update the secrets for the Wi-Fi and then upload the sketch. It takes some time. Okay, now the sketch is uploaded and we can do some testing. So now it's time to make the test. This is the camera, this is the mount for the vehicle. Now I connect it to the remote hub. There is no indication that it is working, but it's working. And once the camera is switched on, you can navigate to the stream address and see the image from the camera. Now let's put the camera on the vehicle. Well, this is not a designer vehicle, but its purpose is just to show you how the camera works. So I put the camera, connect other components to the hub. And this is my remote. It also has the mount for the smartphone. So I put the smartphone here. And this is the camera. As you can notice, video quality is not very good, but you should not expect too much from the components with such low cost. Anyway, it is still possible to control a vehicle with steering which is not very fast. And controlling a more powerful cars can be challenging, of course. I also think that such camera can perfectly fit some kind of tracked vehicle or robot. If you are going to make the same device for yourself, please take care. The camera model gets very hot in a short period of time. This happens because the model consumes a lot of electrical power. Think as if a large motor is being constantly driven at full speed. This also puts a lot of load on the battery inside the hub. Power function compatible hubs are not very durable, so you should not have long races with this setup to save your remote. Anyway, I find this camera quite interesting. Please let me know what you think in the comments, and thanks for watching.